So in this case, we are going to consider as a continuation from what we had on our derivatives, which is the differentiating of functions. This is just like the introduction of our derivatives, guys, because that part we're working with the first principles, binomial theorem, the limits, this and that. So as we are to work with the derivatives in our syllabus, as we are to be dealing with the derivatives, this is the major part, working with the standard functions. So the question is, standard functions, which part are we actually having? What is a standard function? A standard function is the one that we are given something that we are supposed to be differentiating with respect to, and there is a formula, can we say it like that way, that we can use a direct, sorry for that, a formula which is direct for that. We know that derivative by just looking into that derivative. We know, okay, the answer is those are the standard functions that we are talking about. So the first part is when we are given a derivative, let's say y is equal to ax to the exponent of n. This is the basic format that you must understand. If y is equal to ax to the exponent of n, therefore the derivative with respect to x, that is dy dx, it means we are differentiating y with respect to x. Y being a dependent variable and x, the part of x being what? Independent variable. So you differentiate with respect to the independent, with respect to y with respect to x. So the derivative there of y with respect to x can be given by the formula. So this is the idea there. We drop this exponent to multiply here. You multiply it there. So it's like this. A times n. You multiply by that exponent. Then you subtract 1 on the exponent. So it will be n minus 1. You subtract 1. So that's, if you multiply this, guys, it's just going to be what? An x to the exponent of n minus 1. So I want you to be very careful about the standard function. It's x, guys, x, raised to a certain exponent. This is what we have there. Raised to a certain, not 1 over x, no, it's x that we have raised to a certain, it can be negative exponent that we have there. It can be a fraction, as long we see x raised to a certain power, a certain exponent, we can use this concept. We can use this concept where it is applicable, apply the laws of exponents, this and that, because it is not always that you're going to be seeing this. You'll be given something like y is equal to the square root of x. Then you say, I cannot differentiate because I don't have a standard function. No. If we were to rewrite this from our laws of exponents, it means what? Y is equal to x to the exponent of a half. So we can properly see this concept, a number, this x raised to a certain exponent. So therefore, the derivative can be determined of what? Y with respect to x. Using this concept, we have a 1 here. So remember, we're dropping this, half multiplies a 1. Then we subtract 1 on our exponent. So it's just like that. The half here multiplies 1. So it's going to be a half. X to the exponent, we subtract 1. So it's half minus 1, which is minus 1 over 2. Just like that. Just because of our laws of exponents, remember when a number, when a term is raised to a negative exponent, how do you get rid of what? Of that negative exponent. This here, x raised to the exponent of a negative 2 simply means 1 over x to the exponent of a half, which is same as we've got 1 over 2 times 1 over 1. Remember how we had the square root and we wrote it as what? To the exponent of half. So it means we still have the square root concept. Can rewrite in that format. So multiplying these guys, what we're going to have? Numerator to numerator. That's 1. 2 times this, the denominator to the denominator. So that is what we're going to have as the derivative there of y with respect to x. Right? Sorry for that. Derivative of y with respect to x. So when you are given a part where the standard is playing a role, the standard function, this is the concept. Are you seeing that concept? Can x be raised to a certain exponent? If it is so, then drop the exponent, subtract 1. So examples can be differentiate the following functions with respect to x. You'll be given to differentiate with respect to what? All right. So let's say we are given to differentiate the following. All right, gonna just differentiate the following functions with respect to x. The following functions with respect to x. So meaning to say, in that manner, we are supposed to consider divide x. If you're given y with respect to x, like for an example, let's say we are given y is equal to negative 7 over x to the exponent of 2. Like that. Are we having this format? No. So we are supposed to rewrite, guys. This is negative 7 of, if we're to separate it here, if we're to separate this part here, to see it properly to us like this, minus 7 like this, times 1 over x squared. This is not our format. It is supposed to be x to the exponent, not 1 over, not in the denominator. So what can we do? We have to get rid of that one so that it will be written as a proper term of x to a certain exponent. So this is going to be negative 7 times x to the exponent of what? How do you write this on top as a as x to a certain exponent? If it was a negative, it was going to be positive. If it is positive, it will change to a negative. So it will be like this. So meaning to say this is simply negative 7x to the exponent of minus 2 that we are seeing here. We simply take this one up. So to take it up, it changes the sign. It changes the sign from our laws of exponents. We can simply apply this. X to the exponent of n is, k over x to the exponent of n is k, x to the exponent of negative n. If it is a negative, k over x to the exponent of negative n is going to be k x to the exponent of a positive n. Laws of exponents. So this is what you're going to have. So this one was going to be what? Negative 7. We take this one up. It carries what? A negative. So that's x to the exponent of minus 2. We are rewriting back to the standard function. We are not differentiating. Now we can differentiate what is the derivative of y with respect to what? With respect to x. We can differentiate now. If it is in this format, we can drop that exponent. So we are back now to the concept, guys. Drop the exponent. So the minus 2 was going to multiply here. Then we subtract 1 on our exponent. So this is it, -2 times -7. That was going to be +14. X to the exponent, we subtract -2 minus 1. That's what? A -3. All right. Sorry for that. -2 minus 1. So that is going to give us what? A -3. So this is the concept. As a positive exponent, you can rewrite this, remember? So the x is carrying a negative exponent. So it simply means 14 over x to the exponent of 3. So it's just like this, 14 times the part that we are given here of x to the exponent of what? -3. It's 14 times x to the exponent of -3. So it will be 14 times 1 over x cubed. So this is the case we end up here. So we just need to work out as many questions as we can in our revisions as we are trying to have the standard function. All right. So we can given, guys, different questions. Let's say we are given y is equal to 15 over the cube root of x, like this. Okay. So how do we get rid of this? Our laws of exponents, remember, if you are given x to the exponent of m over n like this, it will give us, this is going to be the nth root of x to the exponent of m. So actually, when it is 1 over n, it simply gives us what? The nth root of x. So in this case, as we can see, we have got the cube root of x. From where? From where? From x to the exponent, nth root, 1 over n. So it's x to the exponent of 1 over our n, our number in the root sign, which is 1 over 3. Remember the previous case, when we have this, we can take it up, but it carries a negative. Once we take this one up, it will carry a negative exponent. So 15 as a constant. So it's going to be 15 times x to the exponent of a negative now. Laws of exponents. You see now. The standard function is the one that we need, so that the derivative now can be calculated with respect to x. So the derivative with respect to x can be calculated. Drop the exponent, we subtract 1. So we're going to multiply this. So it was going to be 15 times minus 1 over 3, which was going to give us what? -5. So this was going to be negative what? -5 here. The x, take note, you're subtracting 1 exponent minus a third minus 1. Minus 1 over 3 like this. Then we subtract 1. So that was going to give us what? -4 over 3. Again, just like the previous case, get rid of the negative exponent. We are done here. The derivative is done. The part that we need is the simplification. Our laws of exponents. So if we see it properly here, we can just reverse it here, guys. It's already here. If we check it properly here. If we check it here properly. K x to the exponent of -n is going to give us k, and now it's x to the exponent of what? Positive. It's just a reverse. If you understood it from that way, we can just reverse it that way. So it's going to be -5 over what? X, but raised to the exponent of a positive when you get it down. So the moment, so it's just opposite, guys. To get it up, it takes a negative. To get down, the opposite. The sign, if you want, it's just like getting up, it must change the sign. Getting down, it changes. That is the concept. There's a change of sign from where it was. If the term is on top, you want to write it down, it must change its sign. It was a negative, now it's a positive. If it is down, you want to take it on top, it must change the sign. That is the concept there. If you understand this, you're done. So remember here, x to the exponent of m over n, the nth root here, the nth root of x to the exponent of m. So it's going to be minus 5 over what? The denominator is 3. So it's going to be the cube root of x to the exponent of 4 in its simplest form. Avoid negative exponents. Avoid negative exponents where possible. Write your answers in what? In said form in your simplifications. So this is the idea. So I want you to use this to answer as many questions as you can. And with this concept, again, it also follows that we can even differentiate a constant. Let's say we're given this condition. I want us to see where it is being taken from. We are saying we need y is equal to a to the exponent of x. Let's say it was y is equal to, let's start with linear functions like 5x, 3x, 7x, like that. So let's say we are given y is equal to 5x. For you to differentiate this, the derivative of y with respect to x, take note, this is 1 here. There's a 1 here. So you're going to drop the exponent. 1 times 5. Then we subtract 1 on the exponent there. So it's 1 minus 1, which is what? Which is 0. So it was supposed to be like this, 5x to the exponent of 0. This is what you're supposed to have. But guys, from our mathematics, any number to the exponent of 0 is what? It's 1. So it simply means we've got 5 times 1x to the exponent of 0 is what? It's 1. So 5 times 1 is what? It's 5. So I want you to see the 5 here, the number that you have here, 5 here, became our answer. If you were to do the same thing, if it is 3x, this one, you're going to see that your answer was going to be 3. If it is 7x, if you are given a consideration that you have got 7x, your answer was going to be 7, and so on and so on. So it follows that due to that repetition that is happening, not to say that the standard function did not play a role, no. The standard function is still playing a role. But because of this repetition of these terms that will be, and we're seeing the same answer occurring now and again, we can conclude that for y is equal to ax, the derivative of y with respect to x is equal to a, where the exponent, the highest exponent there on x is what? It's 1. Remember, these are what? Linear function, like a linear term. The highest exponent, what? It's 1. We can conclude that these are examples of the one that we're talking about, the 5x, the 3x, y is equal to 5x, y is equal to 3x, y is equal to 7x. You just take these numbers. Those are your derivatives. Just like that. Those are your derivatives. And also, if you consider even a negative, y is equal to negative 3x, it means the derivative of y with respect to x will be what? Negative 3. But like I said, it does not mean the application of our standard function, this part of our root, is not playing a role. No, it still plays a role, but it is only something that we are seeing happening now and again, so you can take that as a shortcut. Then for constants, if you are given a constant like this, y is equal to 7, and you are supposed to find the derivative of y with respect to x, how can you differentiate a constant? Take note, with respect to x, and we do not have x here. It does not mean that x is not there. X is there. but it's raised to the exponent of 0. So if you were to differentiate using that basic concept, remember, you drop the exponent. So it was going to be 7 times 0. X to the exponent of what? We subtract 1. So it's minus 1 like this. But guys, whatever that we have, as long there's a multiplication by 0, it means we are going to have what? A 0 as our answer. So that's why we consider the derivative of a constant should be equal to 0. Not to say it was not differentiated. No, we differentiated that part. And exactly we got a 0. So we can conclude that also for y is equal to a constant. All right. Y is equal to a constant. Let's say a is a constant or k is a constant, whatever that we have there. The derivative of y with respect to x will be equal to 0. So in actual sense, with this idea, it follows that anything or any term which is not of x is a constant with this idea. Because it is not just like that, guys. It is like when you're given y is equal to, let's say, pi times x like this plus p. We are given to find the derivative of y with respect to x. The derivative of y with respect to x. There we are given pi x. Which format is this that we are considering? Which concept? Ax. The derivative of this ax is going to give us what? A. This is the same thing of our ax. So what is representing our a is what? The pi. It is the pi. So meaning to say, we're going to have pi. Let's move on to the other term. The derivative of this p. What is the derivative of that p? A constant. That's a 0. So meaning to say we're going to have plus a 0, which is simply pi at the end. So any part where you have a constant, just a constant, y is equal to p, y is equal to 3, y is equal to minus 10, y is equal to whatever, as long as they are constants, these derivatives will give us what? A 0. They are constants. So if we do not have x, it can be given in terms of my is equal to mx v squared, whatever that you have, as long we do not have x there. As long here, we are saying with respect to x, and here we do not have x, that part, guys, will give us a 0. All right? That is the idea there. And also on this one, where we are saying where x is raised to the exponent of 1, it also follows that if you are given y's, they can write whatever that they want, guys. M v squared, then we've got the x like this. X is, it means this one represents our constant just like a. So when it is like this, the derivative of y with respect to x, when you're given ax like this, where x, the highest exponent is 1, its derivative is the constant. It means mv squared becomes our constant. That is what it means. Automatically, that's our constant. So it is just, guys, a matter of revision. Do as many questions as you are. So like I was saying, it is just a matter of working with more questions. So let's say we are given y is equal to 480 like this. But it is with respect to x. The question is saying differentiate with respect to x. What does it mean, guys? It means this whole part is a constant. We do not have x there. As it is, the derivative will become a 0 because it's what? A constant. Once you are given that idea, once you know this, where you do not have x, when the question is saying with respect to x and you do not have x, that one will give you a 0. No matter what you are given there, y is equal to pi r squared. We do not have x there. So the derivative with respect to x will give us a 0. where it is linear in this form, where x is raised to the exponent of 1, I do not need to calculate that derivative. I just need to take the answer, guys. If I'm given y is equal to 2px like this, the derivative of y with respect to x according to this format that we are seeing, ax, our answer must be a. What is the coefficient of x? The part that is affecting x is what? 2p. So it simply means my derivative will be what? 2p. That is what it means. Whatever that I'm given, if I'm given y is equal to e to the exponent of, all right. So I wanted something that can be with respect to x, so that we do not confuse each other. But that is the case, no problem. All right. Then moving on to this understanding of with respect to x, they can confuse us. They give us something like this: y is equal to 4x. Then they ask you to determine or to find the derivative of y with respect to t. Guys, it's y with respect to x. Y in terms of x, but here, y with respect to t. So what does it mean? It simply means, guys, this x is just like a constant, just like what we had here. It's just a constant. So the derivative will be equal to 0 because it was supposed to be given like this. Take note, guys. When they say find the derivative of y with respect to t, it means y must be written here in terms of what? Of t. If it was y is equal to 4t like this, and you're asked to find the derivative of y with respect to t, you can differentiate because it is y and t, y in terms of t. So the derivative there would be what? 4. But when it is like this, guys, and they're saying find with respect to t, it means this is wrong. This is a constant as it is. So it will give us what? A 0. Its derivative will give us a 0. So that is the idea there. So I want you to go through out questions with this idea that you have. Questions can be given in different ways where you've got a constant. So apply this information to answer any question. There we are just dealing standard, the basic function that we can have of our functions. So we shall have more functions and also working with the sum and the sum rules, the differentiating of exponential, logarithmic functions, a lot of things that we're going to have that we just need to know before our exams. So like I said, make sure that you go through the membership so that you do not miss any of the other classes that we shall have till we meet again.